Hello everybody. This recording is for selecting Asperger from the catalog. This is the example we have done in a class. I need to review that again for you. Make sure you understand this example very well. Then we move forward to other examples and sample we have for selecting gear and calculating parameters of the gearbox. So in this example, we have an agitator for the pure liquid, uh, which is a gearbox, very simple gearbox pinion gear set going to uh, drive it. So set of spare gears we're going to use for this pinion gear, and the parameters that we have, they are all provided in the next slide. What we are going to do, we are going to pick a steel spare gear with pressure angle of 20 degree. So those are the given data. We have center distance of the gears between pinion and gear. It is 3 inch. Gear ratio is 3 to 1, means number of the teeth of the gear is 3 times more than number of the gear of the pinion. Pressure angle is 20 degree. Material that we're going to pick is steel. The required horsepower is 5.5 horsepower, and this is for service factor. The agitator is going to work between 10 to 15 hours per day, and the velocity of the pinion is 1800 rpm. So we could do some pre-steps by doing some calculation. Because we have center distance, on slide 27 I provided an equation in order to find the pitch diameter of pinion using center distance and gear ratio. So we simply can find this 1.5, and then we could do that for pitch diameter of gear by simply multiply our pitch diameter of pinion by gear ratio 4.5 inch. Then we can find our gear RPM. uh, Gear is driven, so gear RPM going to be, if we use gear ratio with the RPM ratio, which is inverse, and 600 RPM going to be our gear RPM. Then from table 1 on slide 40, based on 10 to 15 hours per day, because we are using agitator for pure liquid, it's going to be uniform, and our series factor is 1.25. Then our horsepower going to be 1.25 times required horsepower, which is 5.5, and the answer is 6.88 horsepower. So we did the calculation in step 1. Now step 2, uh, again in step 1 here in details I explained that how we did the calculation for pitch diameter. Here you could go through the details based on the table that I provided there. Then in step 2 I did the horsepower, 6.88 horsepower, and then 600 rpm in details. So in step 3 we are going to go to catalog to pick up our uh, gear. So remember that when you want pick up a gear, first you are going to pick up driver gear or pinion gear. If I come back to slide 40, in this slide here, I have horsepower of 6.88 and 1800 rpm for my pinion. So if I go to Boston Gear Catalog and goes to Spur Gear. So let me explain here first a little bit about our gear catalog, what we have in a gear catalog. So in a gear catalog, a spare gear starts at page 39. If you go to page 39 here, it is the beginning of the spare gear. Start with brass gear. So first 39 to 51 provides size information and gear codes. First we need pick our gear, then come here and pick the size and gear code. Then in page 51 we have service factor. If we continue that down in page 51, here we have our service factor table, same thing that I provided in slide 40 of your presentation. Then 50 to 59 is gear teeth number and diametral pitch for 14.5 pressure angle, and then from 60 to 64 diameter pitch for 20. So what we have for this question, they ask us to do it for 20. So I'm gonna go to page 60. This is the beginning. 14.5 is the last one, and 59. And now in 60, going to have our diameter pitch and pressure angle 20 degree for different. So what we're gonna do in these steps when we come here, those tables prepared based on horsepower and torque. As I mentioned, we're gonna start with our pinion because driver is important first, then driven. So our pinion had 1800 RPM of velocity, and horsepower was 6.88. So what we need to find, the gear that's going to satisfy our situation should be in 1800 RPM column, but the horsepower here should be equal or greater than what we have over there. So over there we have 6.88 horsepower, but here those are very small value. So I'm going to keep going down to find out the value close to our value, which is 6.88. Look at that, we have 5, 6.22, 6.89. Look at that, 6.89 is a good value because it is greater than 6.88 and it is for 1800 RPM. So this is for pinion. If I pick this one here for pinion, the number of teeth of pinion going to be 28. So based on what I have here in the table, the gear ratio is 3 to 1, means 1 is for pinion, 3 is for gear. So if I pick 28 for pinion, the number of the teeth for gear going to be 3 times 28, 84. So I need to have 84 for the same diametral pitch. You can't have two different diametral pitch because then there is no point of tangency between your gear and pinion. Diametral pitch for both of them should be the same. So 28, 84, the maximum number of teeth that I have here is 54. So means that I cannot pick this gear. So I'm going to keep going down to the next one. This is cast iron. I'm going to move down for a steel. So I have 10 diameter pitch steel, 1800 RPM, 6.5 and 710. Look at that, 710 is the first. So let's have a look to the number I have here. For 710, which is more than 6.88 for 1800 RPM, we are good. So number of pinion teeth going to be 15. So again, our ratio is 3 to 1 here. So means if I have 15 for pinion, the gear teeth should be, the number should be 45. So let's look into the column here. Do we have 45? Yes. So we satisfy our gear ratio that we need. We satisfy horsepower for the RPM that is given. So let's have a look to horsepower here. The horsepower here for 600 RPM, because we calculated RPM for gear 600 is 1004, which is more than what we expect, 6.88. That would be good. But if I were the designer, if I was the designer, so I rather go with 30 because 30 gives us 7.16, which is close to 710 horsepower. I could just save more energy here. 710, 716, these are close, and our gear ratio should be 2 to 1. If a client asks me to do this, I will do it for him with 15 and 45, but I'm gonna recommend this to them that 2 to 1 would be also works for you with 30 instead of 45. That means you are going to save energy, save money, everything. So we satisfy 3 to 1. So we started with the horsepower, we satisfy horsepower in a proposed RPM. Then when we satisfy horsepower, we try to satisfy our gear ratio. So 15 and 45 going to be our answer. Look at that. Reference page 44. What is reference page 44? Remember I said at the beginning of the Spur catalog is the size and dimension. This is refer to that section. So if I type here, this 44 is our 44 catalog page number. It is not the number that we have on top, but I'm going to tap 44 on top and then move it down to find out what page I have. So this page is 41. So I should go to 44. I'm going to scroll down to, this one is 43, and the next one going to be 44. This is 44. Yeah, 44 is here. So what I have, 10 diametral pitch, not 12, steel, 15. So if I want to highlight that, this is one of my gear, and then 45, which is this, another one. So I'm gonna pick this one, YF15 0996. This is the code 9966, and then YF45A 10636. Those are the codes that we have to give to the manufacturer to get the spare gear with 10 diameter pitch. This is pitch diameter 1.5 and 4.5. And if we come back here to our table, we calculated 1.5, 4.5. Very simple. There is other information here that you can obtain. If we go on top here, it say that bore size, how much is the bore size, hub diameter, and it shows here what is it. So first of all, the faith is it is 1.25 inch. So the thickness here is 1.25. Then we have hub projection. Hub projection is given here. It is 0.62 inch. And then we have bore size is here 0.75, 3/4. And then pitch diameter, we have the pitch diameter 1.5, it is here. So everything here is related to the size and dimension here. So you could drive either size and dimension in order to uh, make your box or make your gearbox or make your machine or whatever is the application of those two gears. So let's get back to the presentation. So we calculated step 3. I explain here what you are going to do in order to pick the proper gear. First, you're going to check the pressure angle and gear material and type of gear. So I have a spare gear, steel 20. So I went exactly to 20 pressure angle, steel and spare gear. So my horsepower was 6.88 for 1800 RPM. Based on this, I found my pinion. So I read the number of teeth, then I checked the gear ratio for that. If I could get gear teeth from that table with the same diametral pitch, so we are good. This is our gear combination. This is what I said here. Uh, if the center distance is unknown, you can find it, or if it is given, easily you can find pitch diameter, then make the comparison between the pitch diameters. So those are the steps that you're gonna pick to select. And then here I just said that for us in page 60 in the catalog we found 15 and 45. I just put it here, 15, 710, 45, 1004, which both horsepower satisfy 6.88 and satisfy gear ratio of 3 to 1, and we have 600 and 1800 RPM. And then I said that that's referred to page 32, and this is page 32, explaining the size, the code, and everything for our spare gear. So next step, we will talk about Lewis formula and how we use Lewis formula to calculate uh, load, torque, and horsepower. I hope this works. Thank you very much. Bye.